Now we're going to do some problems. I picked a few that I think will help clear up some things that you might not understand. This is from 8.1, which breaks it down a little bit. Our claim, the mean mu pulse rate in beats per minute of adult males is equal to 69.2 beats per minute. The original claim is mu is equal to 69.2 beats per minute. Check. Okay, good. Identify the null and alternative hypotheses. Well, the null is always the equal, but we don't have to really think too hard about it. It's equal to 69.2. Now, because the claim is that it's equal, then the opposite would be that it's not equal. Mu is not equal to 69.2. If it said that the mean pulse rate of adult males is greater than 69.2 or less than 69.2, my null hypothesis would still be equal, but the alternative or the alternate would be less than or greater than, depending on which it is. And we go to the next question. How you want to work through these problems is find the claim. If it's equal, then the alternate is not equal. But if the claim is that it's less than, the null is still the equals, and the alternate is the less than. So let's go to question number 2. The test statistic of z equals 1.62 is obtained when testing the claim that p is greater than 0.5. Identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. My test statistic, which is my z number, and I'm testing the claim that p is greater than 0.5. Let me draw a picture. The probability is the area under the curve. It is greater than 0.5, so it's right tail. This would be greater, and this would be less than 0.5. So this is a right tail test. Find the p-value. You can use these two tables, but we could also use StatCrunch. The p-value, we have stat and calculator. Since it's a z-score, we want a normal calculator. 1.62. And we want it to be greater than that. And notice that's my p-value. Find my p-value, it's this area under the curve. And we're going to round to 3 decimal places, 1, 2, 3. That last number is going to go up to a 3 because the one next to it is a 6. I'm just going to copy and paste in here and make this a 3. Using the significance level of alpha equals 0.01, should we reject our null hypothesis, or should we fail to reject? Well, if alpha is equal to 0.01, what we want to know is 0.053. I'll just put a box, greater than or less than 0.01. This is definitely bigger than this. That means if I were to draw a picture, and here is my rejection area, and the area here is 0.01, then what I have, 0.53, is going to be in the fail to reject. I will fail to reject. If I fail to reject, that means that I don't know anything. If I reject, that's good. If I fail to reject, it means I don't have sufficient evidence to support the claim. The last example I did, where we talked about someone being guilty or innocent, well, we can't really prove someone's innocence. We can say that they're not guilty because we don't have enough evidence to support the fact that they're guilty. Park officials make predictions of times to the next eruption of a particular geyser and collect data for the errors in minutes in those predictions. The display from technology available below results from using the prediction error to test the claim. Here's the claim. And the claim is that the mean prediction error is equal to 0. My claim is that it's equal to 0, but my alternative would be not equal. That's the opposite of equal. First thing is we have to say what the null hypothesis is and the alternative hypothesis. Now identify the test statistic. The test statistic is not the critical value. It is this observed value. It's the t-value that you're getting from the information that you're given. We don't have the information, we just have a summary. Here, this would be negative 7.51. Identify the p-value. Well, to 3 decimal places is just 0. 1, 2, 3. That 1 is not going to change anything. My p-value is 0. Now we have all the information we need, except we need to also know our alpha was 0.05. State the final conclusion that addresses the original claim. If our p-value is 0, if we were to draw a picture, here's my test statistic, minus 7.51. All we really need is the p-value to be less than the significance level, which obviously it is. If it is, that means it's here in the rejection area. If it's in the rejection area, then we can reject the null hypothesis. If we reject H0 here, we say that no, it's not 0 minutes. We reject H0 because the p-value is less than the significance level. There is sufficient evidence to conclude that the mean prediction error is equal to 0 is not correct because we rejected it. There is some error in the mean prediction. If it was equal to 0, then there would be no error. But since it's not equal to 0, there's some error. A data set includes data from student evaluations of courses. The summary statistics are, so they're giving us all the summary statistics. We want to use a significance level of 0.05 to test the claim. Here's where I need to look. Test the claim that the population of student course evaluation has a mean equal to 3.75. That means that we have equal as our null and not equal again as our alternative. Determine the test statistic. We don't have something like we had in the last problem, so we're going to go to StatCrunch. We have stat. We're given sample information. We have to use our t-stats. One sample, stat, t-stat, one sample with summary. We just fill it in now. Our mean here is 3.61. Our standard deviation is 0.59. Our sample size is 93. That means we can use it because our sample is big enough. Our hypothesis test, we just have to really look here, 3.75 and not equal to 3.75 and compute. And there's our test statistic right here. And we want to run to 2 places. That last number is going to be a 9. Determine the p-value. There's the p-value to 3 decimal places. 1, 2, 3. The number after that is a 4, so I do not round up. Now, we have to be careful about this because this is a two-tailed test. Since it's a two-tailed test, if the significance level is 0.05, that means 0.95 is here in the middle. And this is fail to reject. But I have these ends here. Here and here. And this is the rejection area, both of these. Now, do we reject this? Well, if our alpha is 0.05, that means half of it, alpha over 2, is on this side, and alpha over 2 is on this side. This is 0.025, and this is 0.025. Now our p-value is 0.024. Is 0.024 greater than or less than 0.025? It's a teeny tiny bit smaller. That means it is going to fall in our rejection area. I'm going to reject the null hypothesis, which is that the mean is 3.75. There is sufficient evidence to conclude that the mean of the population of student course evaluations is equal to 3.75. Well, I rejected it. It's not equal to 3.75. I just rejected it. It is not correct. Now we have data. Listed below are the lead concentrations in micrograms per gram measured in different traditional medicines. Use a 0.10 significance level to test the claim that the mean lead concentration for all medicines is less than 17 micrograms per gram. We always know that our null hypothesis has the equal. And our alternative is going to have the less than, which is actually our claim. That looks like the right one. Now we need to download StatCrunch. We have 11 things in our sample. We know it's a simple random sample. We really should do a graph, QQ plot, to see if it's normally distributed, unless it says somewhere here that it is assumed to be normally distributed. No, it doesn't say it. Let's put our correlation statistic, hit compute. Beautiful. That correlation is very close to 1. Look how close it is on that line. We can assume this is a normal distribution. Now we can go to stat, tstat, one sample with data. Our data is in bar 1. Our hypothesis test is 17 and less than 17. Compute. And there's our test statistic. to 2 decimal places. I'm going to change that last 1 to a 2 and check. Determine the p-value. It's right here. 2, 3 decimal places. 1, 2, 3. The number after that is a 4. I do not round up. I just leave it alone. Check. Now we have to state our conclusion, and we don't really need our StatCrunch anymore. State the final conclusion that addresses the original claim. Our significance level is 0.10, and our p-value is 0.019. Our p-value is smaller than our alpha. So again, we reject the null hypothesis because it's in the rejection area. Reject H0. There is sufficient evidence to conclude that the mean lead concentrate for all medicines is less than 17. And there you have it. Thanks for watching.